Hello everyone and welcome back to the new Intro to Python course here on Cybrary On Demand. If you're here, that means you saw the intro video, liked what you saw, and decided to come back for more, and that is absolutely spectacular news for us, and particularly for me. I'm very excited to have you here, and I'm very excited to be teaching you this course. Today we're going to start with Lesson 0. Lesson 0 is called Lesson 0 because in programming, your very first lesson, we will always index from 0. That is key to a lot of different parts of computer science, and it's going to be very important to know because if you mess that up, you can actually break some pretty astonishing things. So Lesson 0, soapbox temporarily over. Lesson 0 is called Some Background. Over the course of Lesson 0, we're going to learn about the history of Python. We're going to learn about the philosophy of Python. And I know that sounds like a weird thing to say right now, the philosophy of Python. But it actually does have an underpinning philosophy, and we're going to talk about that and why it's important. Then we're going to understand the core functionality of Python, what it does, how it does what it does, and why it works that way. So a very, very brief history of Python. It was developed in 1991. Well, it was released in 1991. It was developed by Guido van Rossum over sort of the year preceding that. Guido van Rossum is quoted as saying that he decided he needed a project to keep him busy over the holidays and decided he would create a language to be a spiritual successor to ABC, which can be, which turned into Python. He actually did this as a side project just over the holidays. I have gone to some extreme lengths to avoid spending time with my family and in-laws before, but I have to say I've never invented a programming language, so that's pretty impressive. Version 3, the most current major version of Python, was actually released in 2008, just over 10 years ago. Version 2 is actually still in use in some places, so we're gonna talk about a little bit here. Version 2 of Python is used primarily in organizations that are resistant to change for some reason. A lot of times it's the federal government, sometimes it's big corporations that just have a huge code base that they can't switch over. There are a lot of causes, but fundamentally, it's been more than 10 years now since version 3 was released. Version 2 was intended to be end of life a couple of years ago now, and that got pushed back to 2020 for fear of messing up people's systems, but it will be end of life around 2020. So it's really, really important that we use version 3 and that we upgrade to version 3 because it really is an upgrade. Version 3 is qualitatively superior to version 2 for a whole host of reasons, not least that it actually better follows a lot of programming paradigms. All of that said, the reason I'm bringing it up and the reason why I address it here is because all of the code in this class and all of the programming experience you will gain here will be in Python 3. We will not use Python 2 at any point. So if you're in an organization that needs you to learn Python 2, not the place. And by not the place, I mean not the organization. Don't write Python 2 code. It's not a good idea. So this slide is extremely information dense, and I just want to say don't try and read all of the material on this slide. That's not at all what it's for, and I don't want you trying to do that. However, I wanted to put it up here, and it'll be in your supplemental material as well in a more readable format, because there are a few specific lines that I want you to see and I want to kind of address here. Explicit is better than implicit, simple is better than complex, complex is better than complicated. So those three aphorisms are sort of self-satisfying statements that are sort of self-contained and they are a single point of truth or belief. Those are all contained in the Zen of Python, which is PEP 20, which is actually a Python guiding document. The idea here is that this list of concepts or this list of ideas governs all of the development of Python. It governs all of the concepts that are built into the language that make it function the way it does today. And so the three that I addressed, explicit is better than implicit, simple is better than complex, and complex is better than complicated, are not only the first 3 lines, but they're my 3 favorite lines, and they're really important to this course and really any Python programming you'll do. Because of the fact that when you're writing code, when you're working with code, more often you're going to be reading it than writing it. You only write a program, once, maybe a couple of times if you're rebuilding it for some reason. But you're going to write the code once, and then you're going to have to read it over and over again to sustain it, to fix it, to supplement it. Other people are going to come along and have to read your code and try and understand what it does. And so Python was intended to be a very human-readable language, and when you're writing Python code, you should keep that in mind. Sometimes you can't avoid having complex code, but if you have to write complex code, it's better to write, a couple of lines of complex code and then write a bunch of comments to explain it than it is to have some behemoth monster, thousands and thousands of lines of Python code that don't make any sense. Simple is always the best option, but if you can't be simple, at least don't be complicated. Again, this is a very information-dense slide. It's very small, it's hard to read. This is mostly just here to illustrate. It's not here for you to try and read through. The Zen of Python PEP 20 will be in your supplemental materials. So the design of Python, how it actually works under the hood. We're not going to get super technical with this because this is an intro level course, but essentially what matters here for people who understand, who've worked with programming languages before, who've had to do, like memory management in C or garbage cleanup, all of that is handled under the hood in Python. You don't have to use malloc, you don't have to, associate virtual memory, all of that's handled for you. Python is a relatively secure language in terms of memory safety because of the fact that it kind of takes that out of the user's hands. It's a relatively memory safe language, and it's going to do most of that hard work for you. Python functions on what's called a REPL. There are people who would call that a REPL loop. Those are the same monsters who say things like ATM machine and pin number. REPL stands for read, execute, print loop. So it's not a REPL loop, it's just a REPL, period. Or a rep loop if you must say loop. I understand that this is not important and it doesn't matter, but it does matter to me because I am a pedantic person and this is important to me. But more seriously, REPL, read, execute, print, is the way that the actual the Python implementation interprets your code, the way the interpreter interprets your code. That's the word I was looking for. It will read a line of code. It will gain the context of that line. If it needs other lines for more information or if it needs other data, it will then execute that, turn it into machine code, give it to your system to actually run, and then it will print the results. Now, that's in the interpreter. If you're writing a Python script, it will not print every line. A lot of times, well, in scripts, it's only going to print when you tell it to. And on the interpreter side, if you're assigning the result to a variable, it's not going to print it to the screen because it's being piped to that variable. But the concept still stands. It reads, it executes, and it outputs that information either to print or to some other storage location. There are coding conventions in Python, and we will to some extent address them during the syntax lesson. However, we are not going to spend a whole bunch of time on them because, and this is actually another quote from Guido van Rossum, a foolish consistency is the hobgoblin of little minds, which is to say that it is more important to write clear, readable code that matches the style of whatever project you're on than it is to match every single detail of the Python coding convention. It is more important that your code be easy to use and easy to understand than that you use exactly the right cases for everything. The coding conventions are useful, and I like to follow them, and you should follow them. And feel free to read them. You can see that on this slide is a link, and in the supplemental materials we'll also include that link. But they are not laws; they're guidelines. So a knowledge check. What does REPL stand for? I'll give you just a couple of seconds. Read, execute, print, loop. I don't put loop there because I want to specify it is a read, execute, print, and that is being done in a loop. Which PEP covers the Zen of Python? PEP 20. And which PEP covers the Python conventions? I actually don't know that I said it out loud, but that is going to be PEP 8. Like I said, it's not actually terribly important. It's useful and it's good to know, and you should learn it, and you should look up PEP 8 and read it, but it's much more important that you write functional, easy to read code. So that's all there is for lesson 0. When you come back to lesson 1, we're going to discuss programming basics, logic. We're going to really dig into some Boolean logic, some truth tables. We're going to have a great time. Over the course of this lesson, as our knowledge check suggested, we learned about the history of Python, we learned about the fundamental workings of it, and of course, we learned that it is much more important to be easy to read than it is to be pretty. Thank you all very much, and I look forward to seeing you in the next video.